Disclaimer. This video is for educational purposes only. It demonstrates attacks to raise awareness of security vulnerabilities and teach ethical hacking practices. Important. Always use these techniques responsibly and legally with the explicit permission of the system owner. Unauthorized hacking or malicious use is illegal and punishable by law. Goal. To educate individuals on improving cybersecurity measures by understanding potential attack methods.
During this lab, we are going to try some injections to our web application and see how F5 ASM module is going to help us defend against those injections. So by applying our security policies to defend against different types of injections that could be mitigated using multiple techniques. The first thing is simply the attack signatures. There are some patterns written inside F5 to detect those tries from the attackers related to injection methods like HTML injection, SQL injection, cross-site scripting, and so forth. Also, we can check parameters, values that entered by the client against some special characters, simply because, as we are going to see, that the attacker needs to use the specific characters inside its injection content to be launched successfully, like for example $sign or $. So those meta characters could be checked inside the parameter value, as we are going to see. So let's start speaking about some kind of injections that could be mitigated using F5 ASM module inside Big IP platform. Before we get started, we need to be noticed by two main types of injections that could be existed to most of injections that the type can launch against our web application. Type called reflected, which means simply it will be executed directly on the user's page without storing it into the database of the server side. As you know, I think that the web application is separated into two main parts: the client side and the server side. Client side is related to the front end part, HTML, CSS, JavaScript, all that stuff, and the server side part is related to the database, the back end language that's written to serve the requests of the client from the front end to be processed into the server or the back end part. So the first type here of the injection attacks is reflected. Reflected simply means it's related to the front end part only. It has nothing to do with the server back end part, so information will not be stored there into the database. While stored means the information or the attack trial that the attacker launched against the web application will be stored into the database of the web application, so any other user rather than the current user related to the reflected part will see the same thing launched from the attacker to our web application. The first type is reflected. Only the user that's currently logged into the web application that faced the attack will be affected by this attack. Whether stored, any other user rather than the user that's currently logged in and affected by the attack will also affected by the same attack, simply because information or attack information entered from the attacker will be stored to the back-end part or the database to affect all the other users. Firstly, we have HTML injection. Could be described as cross-site scripting also, because the attacker will try to inject HTML code into web pages. This code could be executed in the client side or the back-end side. Then information could be leaked here once the attacker entered this HTML code, simply because you know that any web application is affected by the HTML code. Any information that you are seeing on any web application is the HTML code. So if the web application is vulnerable to this injection, after the attacker writes some HTML code inside any form of the web application and this HTML code got executed by the web application, information could be leaked, as you see here on this screenshot. You can enter some headers, some paragraphs, and then got executed, and then you can get information from this web application. Cross-site scripting is a client-side injection attack, which is going to be executed into the web browser of the client using JavaScript, like getting cookie and session ID from the client-side session. So dangerous to get the cookie and session ID, and it's always executed into the input field parameters. So you need a parameter that allows the user to enter some data into it. There are two main types of cross-site scripting, as we said before: reflected and stored. So let's take an example here. Suppose that the web application is expecting from the user to enter a text because as a web form, like for example you have a username. Okay, so this is a type of input. You have a username, you have a password, you have some text to be entered. So the web application is expecting some text from the client, and instead of entering the text from the client, the attacker will try to enter a specific format. Inside this format there is a script that could be executed into the web application, and here's an example here to make it simple for you. So suppose that I have an input tag here related to HTML format, and this input tag, we have here a value need to be entered from the client called Bob. So it's text value normally. So instead of entering Bob here to be processed by this HTML tag, the attacker will enter Bob and then it will close colon here and complete the script. So this is a script. This part is a script. So suppose that I copied this part here and I put it instead of Bob. So what will happen? The final code here will be like this. The value here, which is Bob, then the user will enter this part. So until this point here, the exit tag will be here. So this is the first part, will be executed as HTML, and also this part will be executed because it's a script and related to HTML also. So this script will be executed after this exit arrow here for the first tag, which is input tag. Another injection type is called commands to the operating system of the server side. So this is related to the server side part, always found on part of the web application that's permitting you to use operating system commands, like for example DNS lookup. I think you noticed this before. You open a web application. Inside this web application there is a part telling you that if you need to ping another system, try to use this form. So you will enter the command ping by using this form. This means the web application is permitting clients to run some operating system commands through the web application itself, and this could be vulnerable because the attacker can launch some other commands that could be executed into the server side to get information or to see hidden files, to simply try to get the password file of all the users. So anything could be done if the application is vulnerable to this type of attack. So firstly, the web application is permitting operating system commands. Of course, they will be specific commands that defined by the administrator. Suppose that the web application is vulnerable to this injection, so the attacker can enter some other commands that could be executed into the web server part, and then information could be leaked because of this. Like for example here, if there is any part in the web application telling you can use this part to DNS lookup for any domain. So the attacker will type this domain as a part of search, and also will type semicolon to type another command here like ls to get all files and directories that are existed here in this path. Finally, the most popular attack here is SQL injection, and it's about injecting some SQL queries as inputs to the user input field. Because of that, attacker can view, edit, create, or delete database entries. So again, how this attack works, normally the web server is accepting data to be processed by the server part using the database server, and that results could be returned to the client. So here's the format of receiving the queries from client. For example here, I will receive the username here and the password in this part, and then after processing this username and password, I will select a specific columns and tables from the database to be shown to this user. And instead of entering normal username and password, the attacker will enter this result. So for example here, the attacker will part of the password, and instead of typing normal text, it will type this part here. So it will close the password, so the password will be empty, so the web application will receive an empty password, but it will complete its work to complete a specific query here, or 1 = 1. What does this mean? Simply 1 = 1 means this query will select all items inside the database to be shown to the attacker. So the attacker can view every and each single column and table inside the database. Of course, a catastrophe to leak all this information to the attacker. We are going to see, by trying all of these methods on our web application, ASM module is going to help us defend against those kind of attacks. We call them always injections with all types, so whether they are HTML injection, operating system injection, cross-site scripting, SQL injections, and also others. Okay, so let's get started with our lab today. As we said before, in this lab we are going to try some injections with the different types, and we are going to see how ASM is going to help us defend against those types of attacks. Before we do so, we need to review our previous lab and how we created our policy to be able to defend against all these types of attacks. So here on our giant lab we have ASM module here, big IP ASM. We have two main clients here. One is considered an attacker related to Kali Linux. We are going to use this in the upcoming labs. Here we have a normal external Windows client that's trying to connect to our web application here through F5 big IP ASM module and this zone, which we call it always DMZ zone. Okay, so let's review our policy. We have created a security policy using comprehensive template to achieve the most secure features of this template. We also have enforced the attack signatures, and this is the most important part here during this lab. So let's open security here, and then application security, security policies, and policies list. This is our security policy. I'll open it here. Then on attack signatures, you need to make sure that you have most of your attack signatures are enforced successfully. So it's telling you here there is 0 attack signatures ready to be enforced or have suggestions. So simply this means all your attack signatures are enforced, as you see here also. So if you try to search for any attack signatures, you will find them, they are enforced. The next thing that we need to make sure we apply it is simply the enforcement mode, blocking or transparent. In the real world production environments, you need to put your policy in blocking, so any trial from the attacker using injection methods will be blocked according to the mode of the policy. So if we open our policy again here to check that we are in a blocking mode, so as you see here we are in blocking mode, then we are ready to start trying some scenarios to inject some codes into our web application and see how ASM is going to help us defending against all the previous types that we have spoken before in our slide. Okay, so this is our client PC. Again, as we said before, we have two main clients into the internet zone to test our web application. One is related to the normal client and the other is Kali Linux. We are going to use Kali Linux in the upcoming videos because we don't need to use it here. We are going to execute some injections manually through this normal client. Okay, so the first injection that we need to try is the HTML injection, and keep in mind the HTML injection is not considered an attack signature inside ASM module. Using its format, for example as the open tag and close tag, this could be considered as a meta character disallowed value, and then a violation could occur into our ASM module, and we are going to take this as an example. So I will enter here into this parameter which is called username this value related to HTML code, tag h1 hacked it, and then the closing tag here for h1. So this is considered a header, and the secured environments, this shouldn't be accepted into our parameter here. If I click go, I should see that there is no blocking happened here. So ASM module will consider this traffic to be normal. According to me, I don't want this to be happen like this. So again, for now, HTML code entered into our parameter is not considered to be an attack signature because there is no block happened. At the same time, if you don't want to enforce the blocking page for this trial of HTML injection, we can disallow the meta character that's related to HTML code, like open tag and close tag. So let's do so. Here's our ASM module. This is our policy, follow security policy. I'll open parameters here, and then I will search for my parameter that I was trying to run actions on, which is called username. Let's open page 3 here. This is our username. Here, if we click on value meta character, we will find that there are some values here will be allowed here. So by default, they are disallowed. So here you can see that we have those tags related to HTML code are allowed, as you see here, the state is allowed. By default, they are disallowed, but they became allowed because I was trying to see results if I allow those values. So in my case, I need to disallow those characters. So I will check them here, and then I will make them all disallowed. Then I will click update. Okay, so remember, this is the second method we have tackled before when we were speaking about the defending mechanisms of ASM module against injections. The first one was using attack signatures. We are going to see this when we try the SQL injection and cross-site scripting and operating system also. But the HTML code, simply we can block this attack by disallowing the meta characters related to the HTML format. Let's firstly enforce all our parameters because there are some changes happened since the last lab. So I will enforce them all to be applied to our policy. Then let's try to apply our policy to apply our changes. After we apply changes to our policy, we need to retest again the HTML code into our parameter and see the result. So here's our client. Let's refresh this page one more time. Then I will enter this value one more time here. Then click on go. So as you see, the requested URL was rejected because of something happened to our F5 Big IP ASM module. Let's get back to our ASM module to see why the traffic is blocked related to this client. So I will open event logs application and requests. Then let's check this first blocked message. As you see here, there is an illegal meta character into the value. The user entered this value and it's illegal meta character into the value, as you see here. And it occurred 2 main types. Okay, so let's try another attack here. We have completed the first one related to HTML and see the idea of the positive security model and the negative security model. For the below signatures, we are going to see how the negative security model is going to help us defend against those types of attacks. This will be considered as cross-site scripting. This will be considered as operating system command injection, and this will be considered as SQL injection. So let's take the first one as an example. Let's copy this one here. Then I will choose any parameter. For example, I will use this time the password parameter. Then I will paste it here. Okay, so it's password, so it's not possible to enter here password. So let's pick up any parameter to apply this signature on it, to apply this attack on it. So for example, I will choose this parameter related to search, this parameter which is called Q parameter into the development. Okay, so let's choose any parameter to apply this attack on. Let me open login page. Then I will choose this parameter here to enter our cross-site scripting attack. Then click on submit. Request should be blocked. This is the support ID. You can search into your logs by the support ID. Let me refresh your memory about this part. So I will copy this support ID here on our ASM module. I'll click refresh. Of course, you will find it at the first request, but I need to show you the idea of ID. So here I will paste the support ID into filtering process. Then I will click apply. It will show you only the request that was blocked according to this attack signature. Okay, again, so there are multiple meta characters into the value, but here this is our star here, attack signature detected, and it's related to the cross-site scripting, of course. So it was blocked according to the positive security model and also the negative security model. So both models are very helpful for detecting these kind of attacks. There's a very important hint here to be noticed from your side when you are working with attack signatures. Here inside application security and policy building and learning and blocking settings, you have a separate part for attack signatures, and it's customizable and configurable from your side. You can change attack signature sets that could be applied to your security policy, as you see here. If I expanded attack signatures, we will find that there are some attack signature sets. They are applied by default according to the technologies and libraries used in your web application. For example, we are using Apache, so ASM module choose directly Apache Tomcat signatures. We are using Linux, so it used Unix and Linux signatures. Also MySQL. Again, you are the controller for this point here. For example, identifying cross-site scripting existed here into this list. And because of this, I wasn't able to find a blocking message for this attack signature related to cross-site scripting. So you need to make sure that you have all the signature sets related to your attack trials from the attacker existed here, and you need also to make sure that the block action is taken according to the attack signature set. So here we have cross-site scripting, for example, to detect any attack type from this type. Okay, let's try to complete our work here. I'll try to launch another attack related to SQL injection. Let me choose any other URL here. Then I will choose this parameter, for example, to launch the SQL injection. Let me try this first, and then I will type this in the final stage. So for this parameter, I will enter this value related to SQL injection. Then I will click submit. Request should be blocked, as you see here. This is the support ID. Let me get back to our ASM module to see logs. Okay, so let's open event logs application requests. Okay, so this is the first request here, telling me that there is an attack signature, and here it's SQL injection. So it's also blocked because of the positive security model and the negative security model, as you see here. Let me try the final injection method related to operating system methods. So here, for example, I will choose username parameter. Then I will enter this code here. Okay, this is related to operating system codes. So here I can see the result for entering this value. Click go. Okay, so the request was blocked also. Let's try to see the reason for this. I'll click refresh here for the same page, application requests. I think it's related to the positive security model only and no attack signature related to this part here for this parameter. Okay, let me open my parameters to investigate more about this issue. I'll open parameter lists here. Let me open page 3 and see username parameter. Let's open attack signature part here to check the attack signatures applied to this parameter. Maybe there is an execution related to this command that we have entered. Okay, so as you see, we have here ls execution attempt and the state of it is disabled. So I need to enable this attack signature. So let's check this and enable it and click update to update this execution attempt to be matched one more time. Okay, let me open it one more time to check also some other options related to attack signatures. Okay, that's good. Let me apply the policy. Click on apply the policy to start applying changes you have made in the recent actions. Let me retry the same operation again to see the negative security model effect. We are always referring by negative security model to attack signatures. So let me open the same parameter here and click go. Code should be blocked. Let me get back to SM module to see results. Okay, application event logs, application and requests. Okay, let me check the first request here. And as you see, we have attack signature detected, and it's the violation type or the attack type is command execution, and it's related to the negative security model, and also there is an illegal meta character into the value related to the semicolon that we have entered. Okay, so I think during this lab, you got the idea of the negative security model and positive security model and how to use both for detecting and mitigating attacks to your web application. And we have seen a very good example on these violations, which is injections. And we have taken also multiple types of injections like SQL injection, cross-site scripting, HTML injection, operating system codes injection. I think these are the most popular types of injections that could be used by the attackers to your web application.